Yes, welcome to continuation of our discussions on topics in abstract algebra. Today we are going to take some general notations which are used in group theory, which will help us to understand subsequent presentations in group theory. So I welcome to illustrations. Yes, I welcome to general notations in group theory, which will help us to actually understand some of the concepts, improve mechanics in group theory. So I will start with number one, that g raised to power 0 is 1 for any g an element of the group. This is agreed actually. And number two, if you have g raised to power n or minus n, it will be the same as g raised to inverse n times. So g raised to power as an exponent with exponent minus n will be the same as g inverse n times. So this is called g inverse n times for still g an element of the group. Okay. In fact, the laws of indices apply, such as g raised to power m, g raised to power n. We can write this as g raised to power m plus n. So the law of indices for exponent actually apply in group theory, okay, for g an element of the group. And also fourthly, g raised to power m or raised to power n, we can write this as g raised to power mn for g an element of the group, okay. Now number 5, if g raised to power n is equal to e, the identity element, so if you raise g, for example, g into g2 into g3 and so on, when you reach 0 to n you get e, then you say n is the order of g. So that means the number of elements in g, actually g generates a group, and the order is actually n. So we write OG is equal to n. And by OG we mean order of the element g, okay, where n of course is a natural number, okay. Now we also note that for cyclic group, for example, because this happens actually in cyclic groups, the order of g, we write g like this to represent g, g2, g3, dash dash up to gn minus 1, with gn equals e, the identity element, and we then call this the generator, okay. And if we call this now H, suppose I call this H, the subgroup of H, a subgroup of G, okay. So if in G you have an element that generates a group like this, it is called the generator. This element that generates this subgroup is called the generator of the group. And therefore, by definition, a cyclic group A cyclic group, by definition, is a group which contains a generator. In other words, in which or which has an element that generates or exhausts the whole of the group. Okay, so once a group G can be written in such that it can be generated by a single element, which is called the generator, then G is called cyclic group. Okay, so I will come to you to next presentation where we shall see the uniqueness of the elements of cyclic group.